functions, quadratic functions, right? So this function above here, every class, this is the last class we're going to be spending on this, and it's quite possible you all might see this for probably a year again, right? Until I started to do reviews, right? So let's go through some stuff, right? Here is Daryl. Right, so let's talk about some stuff, right? First of all, a quadratic. What form is a quadratic in? A quadratic is of the form, give me it. This is just review, What's the form of a quadratic expression? Let me see who remember. Online, you can better know.
Plus
A what?
squared.
X squared.
Or ax squared, yeah. Plus
bx plus c. It's shocking that only two people saying this. It's only Danny and Daryl, you know. We're going to only rest all here. A quadratic is of the form ax squared plus bx plus c. Everybody good there? And to write your quadratic in this form, what does that mean? Come on, Oliver, we keep saying these things every week. What does it mean? Complete the square. Let's write that down, right? So to write, this is just review. So I'm going to put the word review here. Review, because every week I'll doing this for the past 2 weeks. So a quadratic is of the form ax squared plus bx plus c. To write a quadratic in the form a open brackets x plus h close brackets squared plus k means to, remind me again, complete the
square.
Excellent. Means to complete the square. Two ways you can teach completing a square. The first way is via a process which I find is tedious to churn, right? I rather just show you all the formulas, which is a formula for H, a formula for K, right? So let's lock in, right? What is the formula for H?
B over 2A.
And what's the formula for K?
4AC subtract B squared divided by, over 4A.
Everybody good there? All right. So, yeah, go ahead. Right. So we good there. You can go outside if you want there. Right. So we're looking at this quadratic here. I'm going to write the form for a quadratic right underneath it here. Okay. So what's the form for a quadratic again? A quadratic is of the form
ax
squared plus bx plus. So let's examine this quadratic we were given. They gave us a quadratic which is 4x squared minus 24x plus 31. And they want you to write it in this form, which means to complete the square. So let's write down what A is equal to, what B is equal to, and what C is equal to. Let's go. What is A? 4. Boom. What is B? Negative 24. Nobody don't tell me 24 here. Negative 24 is B. What is C? 31. Can you all proceed to find H and find K? Because I'm assuming that more than 90% of the children did not do my homework. Raise your hand if you did my homework online. Because I think it's just one person did it here. Okay, Amelia did it. Ferguson did it. Pierre. Good, but online people did it. Only one person did it face to face. Who did it? You did it? Yeah. And you, so 2 people. Daryl, and you did it? So 3 people. So I just given those others a chance. So H should be equal to negative who? 3, right? negative 3. Because it'll be negative 24 divided by positive 8, which will give me negative 3. That is each. Everybody good there? Food. Right? I doesn't understand why some of us doesn't be able to do these things, but it's the same thing we do over and over. So let's go. 4 by what is A? What is C?
31.
Minus what is B?
24.
Negative 24. So I do not negative 24 squared separate from this negative here, right? Okay? All over 4 by what? 4 by 4. Because A is 4. Everybody good there? Work out the top for me. Where you get for the top and prayer? Negative 80. Somebody second negative 80. There, I got a calculator. Negative 80. So the face-to-face students work out the numerator to be negative 80 divided by 4 fours are. So negative 80 divided by 16 will be what?
Negative 5.
Negative 5. Everybody good there? So therefore, I can proceed to put now. Therefore, A open bracket x plus h squared plus k is equal to, what is A again? 4 open brackets x. Well, h is negative 3, so it'll be minus 3 squared minus, because k is minus 5, so let's put minus 5 one time. Right? So I completed the square. Everybody good here? Write down if you don't have it, please. Going again. On the axis below, sketch the graph of 4x squared minus 24x plus 31, indicating the coordinates of the maximum or minimum point and the y-intercept. So only two things we want to show. So I write it in red. Who can remind me what the coordinates so review once again, right? Review. All right, let me shift this a little bit. Right, so review. So write same speed with me, please. Or write it over. I don't care if you have it already. Coordinates of minimum or maximum point is given by, talk to me, negative h comma k. Excellent. Write it again. I don't care if you know it. This is my process. This is how I get students to remember things. This is how I get students to excel, by writing over the notes over and over. It must stick. Right? So that's the coordinates of the minimum point. That's review note number 1. Number 2, what is my y-intercept? My y-intercept is the value of, boom. And online belting out these things, but is the value of C. Write it down. I don't care if you have it already. Write it again. This is how we're going to memorize these things. Marie, write it, sister. Come
yes,
in.
sir. In it.
What you see, bro? What you see? All right, good. You didn't miss much. Yes. All right, man. All right. Well, yeah, I gotta talk it over. I know pause it when he walking. Right, so negative h comma k will be the coordinates of my minimum or maximum point. So it'll be negative of negative 3 because h is negative 3, k is negative 5, right? So this coordinate here will be the coordinates of my maximum or minimum point, right? And then what's the value of c from that quadratic above, my children? 31. Everybody good there? So we are C. We have the two things that CSEC wants us to show. Now, just a little review again. Am I able to tell whether the curve will be maximum or minimum from my quadratic? Review. I think I spelled review above wrong now. I think I put EI. I'm sure I put EI. Yeah. All right, there you go. So, if A is greater than 0 means, that's all. I'm going to put, that means, greater than 0 implies positive, right? Okay, so if A is positive, this implies that we have a minimum curve, right? 2, if A is less than 0, which implies a negative, this implies a maximum curve. Everybody good here? That's how you could tell whether a curve is maximum or minimum without E. Right? Is A positive or negative? Positive. So that means it's a what kind of curve? Minimum. No, look at right there, brother. Negative is maximum. Positive is minimum curve if A is positive. Right? Bro, you'll realize that you miss a lot. Reaching late is not advisable in maths class. Right. So write this down, please. Make sure you're saying it again. A sketch is freehand. Right? So we want to plot the point positive 3, negative 5. And we also want to show C is equal to 31, right? So positive 3 on my x-axis, we gauge in it. It's a rough sketch. Can we agree that that'll be somewhere, like say 1, 2, 3? Somewhere here is 3. Everybody good there? Negative 5 on the y. Would that be, let me put that like the lowest point here, negative 5. Right? So where would my coordinate be? Now somewhere right here, where the 2 meet? Huh? This is my minimum point. Okay, that's this here. Everybody good there? Now, my y-intercept, which is C, you can put that quite up here. Right? 31 is somewhere quite up here on the y-axis. It's your y-intercept. Right? Let's draw a curve. You all have to map out this, right? So we're coming down. Boom. Freehand, eh? Make sure it's cutting through the y-axis here. This is your y-intercept. Right? And this is your curve. It could look just like this because remember it's a rough sketch. Right. Equation of the axis of symmetry. Somebody give me it. Excellent. So write it down. The equation, right. The equation of the axis of symmetry is given by x is equal to negative h. So this will be x is equal to what? What was h, guys? Anybody online? What was h?
H was negative 3.
Negative 3. So it's negative of negative 3, which means x will be equal to a negative, and a negative is a
Positive
3. Right? This is the equation of my axis of symmetry. Well, January 2023, right? So they said the function f is defined as follows. This is read as f such that x maps onto x squared minus x minus 2, right? Meaning that f is a function where x, when I plug in x into that equation, you'll get the value of f of x, right? AKA y. So what I want to tell you all is that this notation here is just a fancy way, you can say quote unquote fancy way of writing simply f of x is equal to x squared minus x minus 2, right? Question. All of them, they wrote it, CXC wrote it for you underneath here. You see? So complete the table below and plot the graph for the function f of x is equal to x squared minus x minus 2 on the grid that follows, right? Now, question. Is this a quadratic? Is this expression I just wrote out here, is this a quadratic? What is the form for a quadratic? Belt it out. What is the form? Why you let it look back for that way? What's the form for a quadratic? Ax squared, plus
bx plus c.
Right. Is this function in that form? What number is understood in front of x squared here? 1. Okay? 1 is understood here. What number is understood in front of this x? So is this a quadratic? Why not? What's the value of a, guys? 1, exactly. Right? Watch it here. The value of a is 1. Why does come up? Right. The value of a is 1. What's the value of b? Negative 1. Right? What's the value of c? Well, the whole thing. Come on, guys. This is a quadratic. Right? So we go in. They want us to complete the table and using a scale of 2 centimeters to represent 1 unit on both axes. I guess then they wanted to draw the graph or complete the table below and plot the graph of the function, right? So let's complete the table and let's draw this graph. I think Oli can handle this. Let's go. Right? So we have 2 values of f of x to find, right? For this first column here, what's the value of x for the first column?
-2.
Excellent, Ferguson. -2. You all see that x is -2. They want us to find this. Okay? So you basically want to find f of -2. Whatever you get there would come here, right? What's the value of x to the second missing column? X is equal to 0. F of 0 is what we want to find next, right? So find these functions to me, please. You're just replacing x here with -2, work it out. You're replacing x with 0, and then work it out. Come on, let's go, let's go. Wherever you see x, you're replacing it with -2, right? So if it's x squared, instead of putting x, what do we put? I just said it. -2 to the power of 2, right? X squared, -2 squared. Minus, what's the value of x? The same value of x, -2. And then what do I put? What's the last thing here? Minus what? 2. Everybody good there? So you could either plug this in your calculators, one, work it out, or you work them out separately, right? Anybody plug it into their calculator, what they get it for f of -2? 4, straight 4. Right? So I'm erasing here. Carry one for Daryl one time now. Right. So I'm erasing this and I'm putting 4. Everybody good there? 4. Right? Let's go. F of 0. What am I replacing x with? Let me scroll back up so you can see the quadratic. What am I replacing x with here? 0. So it'll be 0 to the power of 2 minus, what am I replacing x with? 0 minus what? What's the last number here? 2. Right? Plug that in on a calculator. Tell me all again. F of 0 would be equal to -2. Niceness. Put a -2 here. Right? You get this on, Tyler? So you had to draw. Come on, draw your graph now. We have a completed table, right? Before we even roll into the graph, who could give me the coordinates I got plot on the graph? What's the first coordinate here? -2, 4. Everybody seen that? What's the second coordinate? Who's not seen where we getting them thing from? Your f of x axis is your y-axis. It's the same as your y-axis, right? Okay, this is like y. F of x is equal to y. Right? What's the next coordinate? Anybody?
0,
Comma, -2. Next coordinate.
1,
Next coordinate.
0,
Final coordinate.
3, 4.
Everybody see where I get my coordinates from, right? Let's plot. Right, and let's plot. Right, and on my scale, 2 centimeters to 1 unit on both axes. All right? Okay? Everybody get there? 2 centimeters to 1 unit. What does that mean? What I mean there? Huh? From here to here is 1 centimeters. Watch it. From here to here. Let me zoom in, yes? Right, watch it there. From here, from 0, which is in the middle here, right? From 0 to here is 1 centimeters. 1. So they said 2 centimeters to represent 1 unit. So that's not where your first unit is going to be, right? Right, so let me go. So we go in 1, 2 centimeters again, 2. I want to write this in red. I find it in the blue good. I want to write it in red. Right, so this is 0, then 1. Okay, so this is 1 here. This is 2. Right, this is 2. 3. We're coming on this side, Raheem.
Like,
We're coming on this side. -1. And well, we just asked, I just asked space for -2, right? We all probably asked space some more. We're going up here, Alex. We're going up. Positives or negatives? No, brother. Going up is positives, going to the right is positives, right? Other side is negative, and going down is negative, right? So this will be 1, 2 centimeters, 2. Everybody getting problems to plot a point still appear and message me was this group, you know. I can't remember which parent it was, and she told me that their child still getting a lot of trouble with these graphs. A lot of trouble. Right, 4. I'm going down now. We're coming down here, Priya. Right, so -1 and -2. That's all I get, right? Okay, this is the grid that CSEC gave us, so I guess that the points had to fit here. So there you go. What's the first coordinate here, Hill? -2 on which axis, Daryl? -2 on which axis? The first number is on the X or the Y? X, boom. And the second number is the Y. So let's locate -2 on the X. That is here. Okay, Alex? And 4 on the Y. Where would the 2 points meet, Alex? You find where the 2 points going to meet? A dot gone by. Right, so -2 coming up here, and look 4 coming across here. You see there, Alex?
yeah.
I have a first point there, Alex. Right? I correct then? I see Daryl watch it like what is man doing there, right? Let me just make sure. Yeah, Daryl, look, it's -2, 4. Right? For those who not seen how I locate this, you line up -2 on the x-axis. You see it here, Daryl? And then I line up +4 on the y. Cool? Where the 2 points meet is where the 2 numbers meet is where my coordinate would be. Tyler, where they meet. Online, Robin. There's no plating in a Robin. There's a life, you know. Where the 2 points meet is where they are, right? Rishan, are you still getting problems with these things? Or you good there?
No, sir. Good. I actually plot the points already.
All right, that we talk about. You see, one of the reasons of me going through is because I want to be in a real good position when all this start back school, boy. Or it wouldn't be lost. Let me tell you something. I know how hard it is as a teacher to teach in a school environment. Right? So we have -2, 4. That's the first coordinate. Then we have 0, -1. Come, give me the next coordinate. Oh, it's supposed to have it written down. Huh?
0 and negative.
0 and -2. Something feeling wrong here, boy. That's all. So the second coordinate was -1, 0, which is here.
That's what I put my own in.
Yeah. I should have write them. Give me all the coordinates here. Call all the coordinates. It was -2, 4. What's the next one?
-1, 0.
Give me the next one.
0, -2.
Next.
1, -2.
Next.
0, no, 0, 2, 0.
Right. That's the problem. Anytime you see me put like anytime I call a coordinate and it's in the wrong order, it will mess up the graph. Right. So it's 2. What's that, Zaria? 2, 0, right? That's it.
And then
2,
3,
0.
4.
3, 4. Everybody second this. Right? Right. Let me go. So we have it on the side here now. So we just did 0, -1. I mean,
So
0,
I don't know if it's just me, but I see it up to -1, 0.
You see what?
On the side where I write it, I just see it up to -1, 0.
Yeah, I see that too. Okay, let me go. So we have 1, -2. That's here. Everybody agrees? Watch it good. We're going up now. 2 on the X, 0 on the Y. That will be here. Right? 3 on the X, 4 on the Y will be quite up here. That'll be quite up here. Right. Make sure you have this. I'm going to start a plot. Right? All right, let me plot this bad boy here. Insert curve. Right, so you're going boom. We go into here, bang. Then we come in here, bang. Then we come in here, bang. Now my curve will be a little perfect, because I had this tool, but your own might be a little, a little shaky. Talk to me. This thing pass here, boy. I draw it over. I don't like what I draw. All right, we're going again. Any topic to do with graphs, let's take long. Any topic to do with graphs. That's thunder. Whole night I hear thunder up in the bush. See, but it's a storm. Right. Perfecto. Proper thing. Something wrong there. You miss out a coordinate. Watch. You miss out -2, 1. All right. So the function f of x. Yeah, go ahead, Marie. The function f such that x maps onto 3 plus 5x plus x squared. All right? Okay? Is this a quadratic? You know, I've seen here, I've seen plus on top here, and I've seen minus on it here. But I'm minus here, so I guess minus is the correct thing. All right? Right. Is this a quadratic?
So it is a quadratic, but just not in the right form.
It's not the right order, right? It is a quadratic. So what's something? You could actually rewrite this, okay? You could rewrite this. This is the same as writing f of x is equal to, I'm going to put in -x squared first, okay? And then I'm going to put plus 5x, doesn't change position. And is this plus or minus 3 here? What will be understood in front of that 3? A plus or a minus? Plus 3. Okay? So it is of the form ax squared plus bx plus c. It is a quadratic. You can put it in the right order. Okay? Now, we're going to plug in these things, right? For this first missing column, what's the value of x? Let's go. First missing f of x value here. What's the value of x? So we're going to do when x is equal to what? What's the value of x in this column here, my children? 0. This is food enough. 0. So let's plug in. So you want to find f of 0 because x is 0. So you could use this order. I could use the order I write. Let me go with the order that CXC give, right? Let's go with this. Okay? So it'll be 3 plus 5 by what? What's the value of x here? Minus x squared. What's the value of x? 0 squared. Everybody good there? Let's write these things a little better. 0 minus. Right, so let's go. What will this work out to, my children? -2, you sure? 5, I seen 5 by 0, 0. 3, yeah, I seen 3. You see that there? 5 by 0, 0. So this will be 0 minus 0. 0 minus 0 is 0. 3 plus 0 is 3. All right? So this is 3. Everybody good there? What's the value of x in the next column, my children? When x is equal to, boom. So I'm trying to find f of 1. Excellent. So we go in. This is the quadratic we're working with for every single column. Right, Mr. Tyler? So we go in. What we put here, Tyler? This will be 3 plus 5 by what, Tyler? Not plus, minus x to the power of minus x to the power of 2, and x in this case is 1, so it'll be 1 to the power of, let's go. What is work out to be? Let's give me the straight answer. Straight answer.
7.
Where again?
7.
7. Right, let me go. We go down the next side now. So when, next column, when x is equal to, what is the value of x for the next missing f of x value? 4, boom. Right, so we go in. F of what we trying to find? F of what? Boom. F of 4 will be 3 plus 5 by 4 minus 4 to the power of 2. Somebody belt out my answer there, right? In the next one time. 7. 7, so I put 7 here. When x is equal to, what's the value of x in the last column, my children? 6. Let's go. So we're trying to find f of, let's go. So it will be 3 plus 5 by 6 minus 6 to the power of 2. F of 6 will be equal to, what again?
-3.
-3. So I'm going to write in -3. Okay? Ooh. I'm going to say it again. You'll have the benefit of saying it again, right? So on the graph below, complete the graph for f of x is equal to 3 plus 5x minus x squared for -1 less than or equal to x less than or equal to 6. That simply means the numbers from -1 straight to 6. Right? So there'll be -1, 0, 1, 2, going up the road until it meets 6, right? Now, we go, I see CXC plot some points us already, but anybody draw the table? You all have the table there? You all have the table from above? You all supposed to have it? Right? Give me the coordinates. I'm going to write the coordinates on the side here, so you won't make no mistake. Right, give me the coordinates. First one.
-1, -3.
Next.
0, 3.
Next.
1, 7.
Next.
2, 9.
Next.
3, 9.
Next.
4, 7.
I'm coming up here next.
5, 3.
3.
Yeah.
Right.
And 6, -3.
Right. So CXC actually wrote in some of the coordinates to you all, right? So I want you all to draw up this grid and plot out all the my x-axis scale is 2 centimeters to 1 unit. Now peep the y-axis now. What's the y-axis scale? Y-axis. What's the y-axis scale, my turn?
2 centimeters.
No. 1 centimeter to 1 unit. They just counted in twos there. Y'all didn't see that? So they just left out this number here. And this is where CSEC does trick us. This is supposed to be 1, 2, 3. So it's normal. Okay? It's 1 centimeter to 1 unit. Everybody good there? For the y-axis. Okay? So draw up your graph, write your scale above, label y-axis, label x-axis, and let's start to plot points, please. So your first coordinate was already done by CSEC. So this coordinate here, let me get rid of it. Hold on. This coordinate here is actually -3 and -1 that met at this point. Cool? What's the next coordinate? Call out the next coordinate. 0 on the x, 3 on the y, right? 0 on the x, 3 on the y. That'll be here. Everybody good there? 0 on the x, 3 on the y. Priya, you're looking real good. Next coordinate. What's the next coordinate? 1, 6, 7. 1, 7, right? Hold on. I'll put this to charge. Right? So we plot all our points that were given in the table below. So we're going to draw this curve now, right? Okay, so look at it here. Insert curve. We're going. So I'll start in here. Bang. 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 Right. Everybody good here? Right. It's a maximum curve. You got you, Daryl? This coordinate wrong. This coordinate is 0, 3. Where this coordinate here? This one. Where this one? Where the arrow is? Where this coordinate? 0, 3. Where this? Yeah, fix that. Right? So we're going. Write down the equation of the axis of symmetry of the graph f of x is equal to 3 plus 5x minus x squared. Everybody knows what the axis of symmetry is given by. So my
equal
negative each, right? So the equation, you fix it? You see? Right, very good. So equation of axis of symmetry, or let's see how much times I write in these things, is actually, is given by x is equal to negative each, right? Did we have negative h and k here? Right, so I want to show you all something. So the coordinates of negative h will be the coordinates of this point up here, right? This point is actually negative h comma k, which is your maximum point in this case, okay? Now my maximum point, the h, the negative h will be the value of x. And when you come down here, it is actually 2.5. Everybody should have that on their graph, okay? So negative h is actually equal to 2.5. So when negative h is equal to 2.5, negative h is there, lock in. Negative h is 2.5. So therefore, x is equal to 2.5 because the value of negative h is already 2.5, right? Okay? So this here will be the equation of my axis of symmetry, right? Negative 2.5. Then they proceeded to ask state the maximum value of the function. The maximum value, the maximum or minimum value of a function. Write this down, review. Right? The maximum or minimum value of a quadratic function is the value of k, right? So the value of k would be the maximum or minimum value, right? So we go into this curve we have up here. We want to write the value of k, right? So we want k is equal to, so you check your graph and you see what k is equal to, right? So scrolling up, my k here, now every small box, right? Now if he has 9 and he has 10, every small box will be 9.2, 9.4, 9.6, 9.8, and then 10. Everybody good there? Every small box is 0.2. So what is looking like it on my? I find it looking like it on 9.2 or could be 9.3. No, nah, 9.2. I'll go with 9.2. So my k would actually be 9.2, right? So we're scrolling along here. K is equal to 9.2. That's what I am getting. Okay? Check your graph and see if you get the same thing. You're checking the value of k here. So watch, I'm going to draw a line going across, right? So you're checking to see this value here. Right? I am getting 9.2. That's what it is lined up with on my y-axis. That's the value of axis. Reading it again, write down the coordinates of the point where the line, so this is a fresh line, This is the equation of this fresh line. You know what I did not do above here? I did not write the equation of this line. The equation of this line was, well, f of x is equal to 3 plus 5x minus x squared, right? This function represents this curve. Everybody good there? So, let me ask some questions. When a line crosses the x-axis, wherever that line crosses the x-axis, what can we determine? Anybody? If I have a line crossing the x-axis, what can we determine? Online also. When it cuts in the x-axis, what value we could automatically determine, or it is known, it is understood that that value is that. When a line cuts through the x-axis. Okay, so we're going to write that as a note. So write it.
0.
Yeah, go ahead. Somebody was saying it. I hear somebody saying it.
0.
What is 0?
The origin.
No, watch it. When a line, or it could be a curve also, right? When a line or curve cuts the x-axis, when a line or curve cuts the x-axis, the value of y is equal to 0. So y is always going to be 0 when a line or a curve cuts the x-axis. Y is, anytime a line or a curve cuts this x-axis, the value of y is 0. Watch this point here, right? What's the value of y at this point? 0, right? If I have a line cutting through this x-axis, the value of y will always be 0, right? Well, lucky, nah? Okay? So, if I have a line cutting through the y-axis now, what would the value of x be? What would the value of x be on this y-axis? 0? Same 0? All right, so let's write it down. When a line or curve cuts the y-axis, the value of x is equal to 0. So that's the two settings you know when a line or a curve cuts through the x-axis or if it cuts through the y-axis. So right, so that's not a mistake here. So it's when a line or curve cuts the y-axis, the value of x is equal to 0. So we want the coordinates of the point where this line cuts in this x-axis, right? So y is equal to 0. So when y is equal to 0, I can plug that into my equation above. So instead of putting y is equal to this, I'm going to put 0 is equal to 3 minus a half x, right? And I want to find 0. So what I will do in this case, I will carry the half x on this side, so to become positive. Cool? So watch it. If you minus a half x on the right, when you carry it to the left, you do the opposite of minus, which is to plus. So to be 0 plus a half x, which will simply be a half x, is equal to 3. Now they want me to find the value of x. What do I do with the 1/2 when I carry it to the side? No, what is understood? You see that? Divide. Multiplication is understood between this half and this x. So watch it. Multiplication is understood here. So the opposite of multiply is to divide. So it will be x is equal to 3 divided by a half, which will give me what? 3. I don't like this division sign on it. Hold on. It's 3 divided by a half. Somebody will go what that'll be, please. 3 divided by a half, x will be equal to 6, right? So therefore, the coordinate where the line y is equal to 3 minus a half x cuts the x-axis is, what's the value of x? What we just calculated the value of x to be?
0.
No, x is not 0. 6, right? Yeah. 6, comma, what's the value of y? When a line is cutting the x-axis, what's the value of y? 0. Right? So this coordinate would be 6, 0. I'll just fix it something. Sorry. All right, this is a half x 6, 0. Proper thing. Right. So we simply had when x is 0, we plugged it into the initial equation, which, well, of the line, which is y is equal to 3 minus a half x. You replace the x at 0. What we get in? Y is equal to? Nobody can work it out? Y is equal to what?
Equal to 3.
3. Very good. Right? So the coordinates of the point where, come on, you're right. Line crosses the y-axis is, what was the value of x when a line crosses the y-axis?
0.
0, comma, what did we just calculate the value of y to be? 3. So we have our two coordinates, right? So the next part of the question asking us to do. On the grid above, draw this line, right? Now, in order to draw a line, to draw the line, y is equal to negative a half x, we must have two coordinates on the line, right? You must have two coordinates on the line. And we just found two coordinates on the line. We found one point where the line cuts the x-axis. What were the coordinates of the point where the line cuts the x-axis?
6, 0.
coordinates of the point where the line cuts the y-axis.
0, cover 3.
So we're going to plug these 2 points, okay? So you're still writing? I want to scroll up. I want to scroll up, guys. Right, we're going up. Okay? So 6003, right? Let me plot them points. Let me plot them bad boys. Okay? 6, 0. 6 on the x-axis, 0 on the y. Where would that be, boy? 6 on the x-axis, 0 on the y. Would that be here? Huh? Everybody good there? Let me put it in a different color. Hold on. Okay, let me put this in green or something. Yeah, green. So we here. Boom, bang. 6 on the x, 0 on the y is on the x-axis itself, right? What's the next coordinate? 0 on the 0 on the x and 3 on the y. That's actually the same point here. Okay? That's the same point here. So I'm going to draw a line from here. Okay, I wouldn't really go beyond the line. So we're coming from here, going all the way to here. All right, they could go through. All right. And the coordinates of this point, right? Not the coordinates. The equation of this line is y is equal to 3 minus a half x. That's the equation of that line. Okay, so draw that line for me, please. So if we have a pair of simultaneous equations where one is linear, so to solve a pair of simultaneous equations where one is quadratic and one is linear, using a graph, it will be the coordinates of the points of intersection, right? So it will basically be the 2 points, or the two points where the graph and the line meet. Well, the curve and the line meet in this case. Okay? So they want the coordinates of these 2 points of intersection. We're going to go back up to the graph, but you'll write on this first. So we're going to write down the 2 coordinates for the points of intersection, right? Right. So as zooming in here. Now this is one point of intersection between the curve and the line, right? What are the coordinates for this point looking like to you all? This number here will be what? 5.5? Everybody agrees? Yes, 5.5, right? And what is it lining up with on your y-axis? It's looking like 0. I find it look like 0.3 or 0.2. What you always say? What your graph giving you all? Everybody graph might give something different according to how you draw your curve. My graph, I am getting 0.2, 0.2, and well, not 0.5. 5.5 on the x and 0.2 on the y. That's what I'm getting for this coordinate here. 0.2. Right? And for this coordinate here, which is the next coordinate of for the next point of intersection, it is 0 on the x, 3 on the y. That one easy. This one here is a little problem, right? So we're going to write it down. All right, we're going to write it down. So the first coordinate for the point of intersection would be 5.5 on the x-axis and 0.2 on the y-axis, and 0 on the x, 3 on the y. Three on the y. Okay, this is the solution to your simultaneous equation above, right? Everybody good there?